Hey everyone, this is FixReef, and today we have a special type of device here. This board, and it came in just like this, in this particular state, but this board is from Alcatronic, one of the early devices that was able to measure and test alkalinity in your water. So this came in as just a board in just this condition, and what happened to it, according to the customer, is that um, Alcatronic developed a leak, and the water leaked into this area over here, and you can see a fairly significant damage. This connector over here is a power connector, and what I also got with this unit is the other side of the power connector, and it looks just like this. So of the two pins, one's completely burned off. So the short was so significant and was so strong that it completely burned one of the fairly thick pins. So today we're going to attempt to fix this device, but before we do so, let's take a look, because this is the first time I have an Alcatronic in for repair and on my channel as well. So I think that this is going to be interesting for many of you. If you would like this content to continue, please like and subscribe. It helps me, it motivates me to create more content like this for you. So let's take a look at what we have here. Again, this is the first time I see a board like this, so I'm going to be investigating along with you. So the first thing that jumps out at you is this red board over here compared to everything else. This red board is actually just connected on here, through these 3-pin connectors on each side. And this board, let me zoom in. This board is a fairly common PH board for Arduino, right? Costs about $40, $50 to get one of those, at any of your favorite suppliers, and it does PH measurements. So they just decided, instead of implementing their own, they'll just plug in a solution that's already exists on the market. It's kind of not a bad idea if you can justify the cost. All right, so the other thing that jumps out would be these two controllers. These two controllers are identical, believe it or not, but these are the 8051s. I had to look them up. I haven't seen them before. They are 8051 controllers in this type of packaging. For those of you who don't know, 8051s are 8-bit old school controllers. They're very old, decades old as far as the technology goes. But they're very common in inexpensive implementations that don't require a whole lot of power. You can see here that 2 of them are being used. Other than that, obviously, there's a relay, some other connectors here, support for connectors. There's a USB port for some reason. Again, I'm not very familiar with Alcatronic, so I don't know exactly what everything is for. Over on this side, this looks like stepper motor drivers. So there are probably stepper motors that pump the water, and some type of sensors that plug into the ports and supporting circuitry around them. I mean, the board by itself doesn't really look too bad, other than this corner. This corner is really, really horrible, but everything else is fairly clean. I am not actually seeing any type of damage to any of the controllers, but doesn't mean that there is no damage at all. My biggest concern, what would make this a very tough repair, is if any one of these two controllers is fried. And the reason I say that this is a concern is, just look at this. These 6-pin connectors are some type of programming connectors. So they provide power to the controller, and they provide some type of communication to the controller. I don't know yet what they are. But over on this side, this seems fairly safe. But over on this side, this connector here, it already has some corrosion on it. Bottom line is that if high voltage ended up somehow touching this, it immediately fries this controller. So big question of whether or not this is actually working. Notice these check marks done with like a pencil or something. There's a check mark here, there's a check mark here. My guess is that during post-production, these were checked out as those that are programmed. So they probably produce the whole board, they plug in the programmer, they program the device, they check to mark that it's programmed, they do the same here, check to make sure that it's programmed. So yeah, now let's focus on the damage here. So obviously this connector will have to be replaced. This is a disaster over in this corner. Quite a bit of damage to the board itself. It looks like some of the board layers got delaminated over here. So that's a concern depending on what type of V is and what type of traces are going on here, because that, whatever there is, it more than likely got disconnected. Looks like some kind of a thermistor, but this thermistor is going over to stepper motors. Um, so that's that. And then there is this circuitry. By the looks of this circuitry, I would imagine that this is some type of voltage regulator, very similar to those used by Apex on EB832s and many others that take higher voltage and convert it into low voltage, like, I don't know, 5 volts, 3.3 volts, whatever they configure this as. So it's right here in this corner. High voltage from the power supply coming in, and then lower voltage is coming out. What if something here gets shorted and high voltage goes into the controller? Then we have a problem. But the last issue that is also an indicator that this might be a problem for either of these two controllers is this. Notice the direction of flow here. So 19, well, I guess I have no idea what the input voltage is for this guy, but has to be over 12 volts, I would imagine, is coming in here, gets converted. After conversion, it has to go through filtering. It looks like we have a diode, a capacitor, or maybe one of these two, or both of these capacitors, and the inductor right here. The inductor out of the filtering circuit is straight input voltage into the controller. This gets 20 volts or whatever the input voltage is. This controller is dead. The good news is that visually I don't see anything fried here, but it does not mean that this is not fried. Also good news is that STC controllers are very cheap, incredibly cheap Chinese controllers. Given the current parts shortages, I hope that if one of these controllers is dead or both of them are dead, they can be acquired from China fairly easily. There is no way I can find this likely in the US, and I will have to go straight to China to actually get them. It's one of those rare cases where while I don't like buying parts directly from China, this is the source of these parts. China is the place where this was designed, manufactured, and so the only place to get them would be from China, and that is the right decision. Let's take a look on the other side of this board. Not a whole lot going on here. There is definitely damage. All of this is damaged. Notice that the thermistor that again provides power to stepper motors, or not provides power, but conducts power from the power supply directly to the stepper motor drivers, that got significantly corroded out, which suggests that there is damage um, uh, to the thermistor, but we'll have to find out. And look how this just comes off. Look at all this mess. There's probably more with here. The good news is that there is not a whole lot of traces going on this side, so I'm not too worried about V as being damaged, the traces being damaged. The only trace seems to be this, and it's a huge trace and it's intact. So I think we should be good from that perspective. Okay, so I think that the plan of attack for this repair would be to first clean up this area and find out if the power circuit is working, and then find out if the controllers are working. I have a mild short on here, which is not a permanent short, but it's clearly the resistance is not where it needs to be, and it's not surprising given the condition of this connector. So let's get rid of the connector, maybe even remove the thermistor. So clean this up, run this under the ultrasonic cleaner, and hope for the best. All right, getting the connector out would be my first challenge. It may not be as bad, but at the same time, this is a massive mess. This is completely burned out. There's a hole in here, but this is kind of still okay, and I can actually see some copper and stuff underneath. So let's clean this all up. Not a whole lot going on this side, so let's see if we can get this pin out. So this may not work, but let's see if we can put some fresh solder to increase the surface. Seems to be working. And it's coming out, and it's gone. Just as simple as that. All right, so the connector is out. Complete mess. Complete melted mess. And this side of the board doesn't look much better. Let's look on this side. Oh yeah, yeah. Lots of significant mess here. It's probably the best we can do, just scraping things off on this side, and not a whole lot better than the previous over on this side. Okay, so this is the best I can do without ultrasonic cleaning. But before we do anything else, let's take a look here and find out what was supposed to be happening here if this was a good board. Because I need to know where the traces are and how to fix it once I have that knowledge. So hopefully you can see this. There is a divider between these two planes. Right along this way. There is definitely a burned board over here. And the moment the board burns like this, it starts conducting. So everything has to be removed. Anything that is that dark, that burnt, has to be removed before we have any chance of making it work. Let's see how huge of that hole is here, and who knows how far that burn goes even under the copper plates. And that type of hole we get by just removing some burnt board. This is crazy how deep it is, how thick it is. And at this point I have to wonder if I will be able to actually clean this up, or if I will have to cut off this piece and basically start fresh from this rest of the board. And so that's that. And again, on the other side, the more I'm working on this, the more I realize that I probably will have to just cut off this piece of board, because the amount of damage is absolutely incredible. But when the damage happens here and it's that bad, that actually gives me hope that the much more sensitive components down the line have not been damaged, because most of the damage ended up being on the board itself. The only reason to salvage this would be for the integrity of assembly, if this corner plays some kind of role in keeping the board stable inside the unit. Okay, so just to give you an idea of what has just transpired here, look at all of this mess. This was all the burned, burned carbon from inside the board, and we have a huge gaping hole in this corner here. So there's absolutely no way we can put a connector that is comparable to the original connector in here. And moreover, I am questioning whether or not I actually want to keep this corner intact. I think most of this will have to be cut off. But before I cut anything off, I need to make sure that this board is not multi-layer and there are no traces inside that we can damage if we cut everything like this way. The mounting hole looks like is over here, one of several mounting holes, so that's good news. So that's not going to get damaged, but this is a massive mess. Okay, so I cleaned up all I could, and I actually tested some of this copper. Both big planes on copper on both sides is basically ground, and the only positive line that I could find is indeed this thick trace that goes to the thermistor. And by the test of the thermistor, it looks like the thermistor is okay. A little bit of corrosion, but it's okay. So here is my plan to test this. I'm going to connect carefully the test power supply to the positive and the negative parts of this board, provide lower voltage than then it takes definitely a whole lot less amps and see what works. The first concern rather, is this buck converter or the voltage regulator. This is very similar in the idea of how voltage is being converted from the original input voltage into either 3.3 or 5 volts, whatever the output is, to what Apex does in the majority of the units, although the controller, while it looks identical, is not actually the same. So, and there is a very high chance that this is damaged. So I want to make sure that that's the case or not the case, and we'll move forward from there. So what I did is I tested for resistance between the negative and the positive traces, and it's in mega ohms, dozens of mega ohms. So I think whatever we did cleaning up all of the burned board on the inside actually worked. So I think it's kind of somewhat safe to now attach the power supply to this and see if we can get it to work. So to attach the power supply, I already have a little bit of solder around this area, so I can just attach a wire here, and then I can attach a wire over here, and see if I can get a connection. All right. Well, the moment of truth. Let's find out. It didn't short out, and look at this. At least something's working. The LED on this pH controller is actually functioning. Is this it? Did we just fix this? Is that all what's broken? That's possible. Let's find out. Let's get some voltages figured out. So let's do ground and thermistor. And it looks like almost 12 volts. Now let's do ground and voltage regulator. And that is 5 volts. We actually have 5 volts out of the buck converter. It did not break. Now, how awesome is this? Okay, I also found a test point that was marked as 3.3 volts over here. Let's see if that produces anything. No. But that may or may not be a problem because nothing's really connected to this. I don't know if this is supposed to be a valid test point. But the fact that we get 5 volts out of this is actually fairly amazing, given the damage. Let's find out if we get power on these controllers. 5 volts, 5 volts. Both of these controllers seem to be on. I think this is it. I think this is it. Unfortunately, there is not a good way for me to test these controllers here, these drivers for stepper motors and these type of things here, because nothing's connected and I don't have the rest of the equipment here. But this seems very, very, very promising. Okay, so the board is right out of the ultrasonic cleaner. The copper is much, much shinier. For the most part, all of the corrosion is gone. Of course, we have a huge gaping hole here, and the same type over on this side, although this is all good. So what I need to do now is I cannot install a new connector when the hole is like this and it's all in a giant mess. So I'm gonna have to, I have connectors like this here that I can use. They're about the same type that was used in the original board, just perhaps a little bit better with the locking mechanism. So what I'm going to do is I'm going to attempt to move the connector and install it, just shift it a little bit up here, because this is, I have to be careful because this is a mounting hole, that's where a screw goes. This is just a big mess, but who cares? So if I just install it somewhere in this area, I should be okay. And on the other side, we can see that the ground is all here, it doesn't matter where it is. And this is the power coming in, that big trace over here. So as long as I drill a hole here, and connector comes through this, then I can attach all of this properly to the new connector in the new place on the board. What I have to watch for, of course, is that this is all ground here. So I drill 2 holes, I install 2 metal pins. I need to make sure that my power pin, which is going to be on this side, does not actually touch the copper. So I'll have to cut out the copper from this area well around the pin so that it doesn't touch. So let's drill some holes and reposition the connector. All right, so I got 2 new holes drilled here and here. And what's really nice is that it fits almost perfectly for the new connector. So the connector is going to go in something like this. It is still far away from the mounting hole so that there is a room to put the screw in, and it's also away from this cutout where a piece of plastic for the case of the Alcatronic goes in, so it should be all right. And on this end, on this side, we still have really good amount of trace that carries positive lead and definitely plenty of ground. So this will go in easily. Like I said, the only challenge remaining here, other than cleanup of all of this mess here, is making sure that this ground does not touch the pin of the positive lead of the connector. So we'll need to cut a lot of this copper out around this area on the ground plane. But we need to do this anyway, cleaning all of this mess up. So let's get under the microscope and clean it all up. All right, much easier to see at this level. Let's now cut out all of the copper that has been delaminated from the board. They are using some very, very thick copper. Here, this is crazy how thick this is. You can see as I'm poking through the copper how much internal damage the board took from the short. Or we can just use Dremel on this. Oh, now over on the other side. Okay, so to clean this up, I'm going to use Dremel with the smallest grinding bit that I have. Have to be very, very careful and very precise. Working with Dremel under the microscope is not an easy task. Let's give it a try. And that should be sufficient. Okay, doesn't look too bad. The idea is that the pin that we have is not going to touch the ground plane here, and instead going to go straight to the positive trace on the other side. This can touch the ground all at once because this is the ground. I also have to be fairly careful with the copper because copper dust is obviously conductive. It cannot get into anywhere near the controllers and accumulate there. Okay, so this is the final product of preparing the holes. I do not see any copper conducting from the ground over to the power trace, so I think we should be good to go. It's time to install the new connector. So the connector without the top part is going to look just like this. It's going to look almost identical to the original connector that we had here, which was this. Let's see if we can have it set up. Let's see if we can solder it in. Because everything is kind of new, let's add some flux everywhere. And now let's see if both of this will take solder. Need to have plenty of solder because Again, this is a connector that is supposed to get pulled and stuff during install and uninstall and maintenance. So need to make sure that there is plenty of copper that's holding it all together. All right, so this looks real good. While I'm here, before I clean up, I also wanted to make sure that the thermistor is properly connected, because it looks like it's sort of moving in the air, and it's not a good idea. I'm actually going to get under the microscope to get this done, because this is fairly small. Okay, soldering should be fairly straightforward now. Let's get this pin that we can actually solder to this side, and because that's a fairly important one. That's the one that's connecting the positive pin from the input to the thermistor. So this needs to work. And it needs to be done on this side, or otherwise it's a major pain to do it on the other side. Okay, let's give it a try. Come on, oxidation giveaway. Okay, I think we're making good progress. Okay, I think we got it. Except that I spilled some solder onto the ground plane as well, so we'll take that all out. It's good enough. All right, like I said, there is absolutely no point in soldering to this, because there is no copper left. There is nowhere to solder to. And just like that, we have really decent connectivity. And since we are here, we might as well solder to this a little bit. And that's going to hold it really good. Yeah, and look at this. This looks really, really clean. Looks really good. Again, I don't have to worry about this pin over here not being connected and soldered on this side, because there's nothing to solder to. And instead, we have a nice and clean soldering blob over on this side. Which reminds me, this also needs to be cleaned up. All right, time to test, at least at this point. Now I don't have to solder anything. I just connect my power supply to the connector pins, and let's give it a little bit of power. Looks like the LED is on. Let's find out if we have any type of voltages. All right, so ground. And let's test this. 5 volt comes up. Okay, so what else do we need to do with this card? What I need to do is just cover everything with new green mask, have it all cured, and I think this board is going to be fixed. All right, now that the board is repaired, the last thing remaining is fixing the cable that's supposed to go into this connector. That should be fairly straightforward. Just cutting off the old stuff. and attaching it to the new connector. All right, before I finish this repair, let me go over a few interesting observations that I found on this board. Again, this is my first time looking at Alcatronic boards, so I think that this is going to be interesting for some of you. This whole power circuit that this unit starts with is not really a very common thing. I suppose those who designed it figured, well, why do we need all kinds of protection at the input? Just go and take the input power pins and lead them straight into the buck converter. What's about all of this reverse polarity protection or over voltage or under voltage protection? Let's just go ahead and just go straight into controllers. Luckily for this user, it did not cause a major damage this time, but it does not mean that it's going to happen next time. What you would typically see here, I'm not a big fan of buck converters like this that have a built-in MOSFET. They don't last very long with the built-in MOSFET. Built-in MOSFET doesn't get power and heat dissipation done properly, especially at high loads. I would have implemented a separate MOSFET and a separate controller for it that would drive the power conversion. I would have implemented over voltage and under voltage protection, reverse polarity, although there is a diode over here, so I suppose it does something. So very, for the cost of the device, this implementation is extremely basic. Most modern designs include a whole lot more of power circuit protection up front here. So this is very similar to what a Neptune does, not very impressive at all. But let's just hope that it works for this customer. But let's see what we've done. We've cleaned this whole board very nicely. We're very lucky that none of these two controllers have been burned, at least not that I can see. Again, I can't really fully test this because I don't really have anything to connect this to. We had to clean up this area of the board that got most of the damage. The damage was so severe that we could not have the connector placed where it belongs. We had to shift it over, we have to reposition it. We had to drill holes in the main board, make sure that everything works. And it seems like it's working. At least the light comes on. And the power consumption is consistent with what would a bare bone board take with just basic controllers that currently don't do anything useful. Well, but this completes this repair. If you enjoyed it, please like and subscribe, and I will see you next time.